All right, so in Module 9, we're going to be discussing COPES questions a little bit further. Again, I'll have a separate video describing how to do the literature review searches. And also, I'll go into data analysis a little bit regarding visual analysis, descriptive statistics, measures of central tendency, variation, and measures of trend. So regarding COPES questions, again, just to review, they're client-oriented, practical evidence searches. So questions from daily practice that are posed by practitioners that really matter to the client and their welfare. So an example of a COPES question here, potentially for women who self-injure, is DBT or another treatment more effective for reducing self-injury? This is a good COPES question because it specifies whom the intervention is for women who self-injure, and also the potential intervention that might be used, being DBT. And it's also got the Boolean of or here, or another treatment more effective for reducing self-injury. Another example might be among children who are overweight, what are some of the social problems that they may encounter? So again, children who are overweight being the sample here, and what are some of the social problems that they might encounter? A couple more. For cancer patients, that would be the population of interest. Will a support group or individual therapy be more effective for reducing stress, depression, and anxiety? And one last COPES question for mothers of children who die of cancer. What is the emotional experience of grieving like for them? So this is just more of a descriptive question. This isn't really trying to prove which intervention is more effective, but more of just trying to understand the population of interest, or more description of what it's like. So a COPES question allows you to incorporate all elements of evidence-based practice into your clinical work. That is, the client type and problem of a COPES question allows you to address the clinical state and circumstances of the evidence-based practice model. So we can see an overlap of clinical state and circumstances with client preferences and research evidence all come together to help inform your clinical practice and your clinical expertise to provide evidence-based practices for your clients. So visual analysis is the start of all real statistical analysis because we want to look at our graphical data first to see if there's outliers or any kind of trends that might be identifiable. Visual analysis of the single system design is looking at the data to find patterns and aid in our interpretation. And the visual analysis is going to help us look at several different properties of our data. The first of which being the level, which is the magnitude of the client problem operationally defined. So the magnitude of the client's problem is indicated by the data at any point. So this is an example of a client who is prescribed 10 days of pills who's been diagnosed with AIDS. His level in terms of being compliant with his medication during the baseline are about 30% compliant on day 1 and 40% compliant on day 2. His level of compliance on day 3 and 4 of the intervention is about 80% with prescribed medications. So again, the level is the magnitude of the client problem as described at any point in the data. So in that example just reviewed, there's also been a change in level between the baseline and the intervention phase, which is called discontinuity. And discontinuity can be either positive or negative in terms of client improving. They can be positive discontinuity, which is a significant improvement associated with the intervention phase, or negative discontinuity, which we typically don't see, but can still be a good warning sign that they're not improving and maybe we need to try something different. So there's a difference between the client's level of medication compliance at the end of baseline, day 2, and the client's level of medication compliance during the intervention phase, starting at day 3. And this change in level between the two phases is called discontinuity. And this is positive discontinuity because the client is becoming more compliant in taking their medications. We can see there's about a 40% increase in compliance from day 2 to day 3. So a second property of graph data is stability. And stability is defined as clear predictability from a prior period to the later one. That is, stability is a visual analysis of single system design and can be best characterized as predictability of a client data from one phase to another. So let's take a look at some examples here. So because these lines are stable, the intervention data can be predicted from there on. If we see that clear straight line during the baseline phase, we would kind of predict that it would continue on to the intervention phase. So here's another example. The baseline data, even though they show an upward trend, are still predictable. That is because the baseline phase is showing a stable, increasing trend. We would expect that without an intervention, it would continue to go in that way. And here you can also notice the positive and negative signs. So there's a positive, stable, increasing trend. So maybe we could think of something like somebody who's focusing more on studying habits. During the baseline, each day they were studying a little bit more from one day to the next, and we would expect, even without an intervention, that their study habits would continue to be in a positive, increasing trend. So let's take a look at a real life example here about a client information regarding unmanaged diabetes and renal functioning. So these two lines here kind of indicate what renal functioning would look like in managed diabetes versus unmanaged diabetes. So the blue dots indicate what would be expected to happen if the diabetes was unmanaged, and we would see the certain level where the person would eventually need to get on dialysis. And we can see that there's a much steeper slope, whereas managed diabetes over time, a person could maybe potentially go the rest of their life without ever getting to the point where their renal functioning was so low that they actually needed to get on dialysis. So again, here we can see stable trends in baseline help us to predict what would happen in the future based on clear patterns that we can already begin to see. So we talked about level, continuity, or discontinuity. And a third trait is called trends, or a slope. That's directionality of the data. And data may show an increasing trend or decreasing trend or no trend, or even flat data. So let's again look at some examples here. So with this first example, we can see an increasing trend in the data, and we also have an example of a decreasing trend. So assuming a higher score is better here, the first example is a positive increasing trend, and the second is a negative decreasing trend. But that would only be true if a higher score was better. So potentially if this is minutes exercise per day, it would only be a positive increasing trend for the first one, as if that's something that we wanted to see more of. Versus it would be a negative increasing trend if it was something that we didn't want to see more of, such as cigarettes smoked per day. So you need to know whether this would be positive or negative based on what the outcome variable is. So a couple more examples here. The first example, we have a no trend, no slope data, and also a pattern that varies irregularly, which in effect is no trend because the data it varies so irregularly. And a fourth property is whether there's improvement, deterioration, no change, or ambiguous pattern from one phase to the next. And I'm hoping to show some examples where we can apply these to real graph data and identify whether there's discontinuity, stability, or trend. And the fourth property is whether there's improvement, deterioration, or no change, or an ambiguous pattern from one phase to the next. And I'm hoping to look at some examples here where we can apply these properties to real graph data and discuss discontinuity, stability, and even trends that we may notice. And you can see the write-ups of more of these in the notes from the PowerPoint handouts that I'm going to upload to the website. But an example of how you can write this up, notice the positive and the negative sign. The client's problem exhibited a stable, no trend pattern during the baseline period that would have continued without intervention. Upon completion of the intervention, however, the client's problem improved. The intervention was associated with an overall positive change in level and a stable increasing positive trend in the client's problem relative to the baseline period. So there's stability, trend in both phases, flat trend in baseline, positive increasing trend in the intervention. And in another example, the problem exhibited a stable, no trend pattern during the baseline period that would have expected to continue into the intervention. But upon completion of the intervention, the client experienced deterioration. The intervention was associated with negative discontinuity, stable decreasing negative trend in the client's problem relative to the baseline period. So in this case, the client would have fared better if no intervention had been implemented. So what would you do if you were a practitioner and having monitored this client's intervention? I would say it's probably best just to stop the intervention, or maybe try something else completely different, or maybe try a different therapist. Hopefully that's not the case, but either way, it's a good warning sign that you need to try something new. So here the client's problem exhibited a stable, increasing positive trend during the baseline period that would have been reasonably expected to continue on to without the intervention. The client's problem improved even further with the intervention data, and it was associated with positive discontinuity here, because we can see the gap from when the intervention started. There's a clear boost in the outcome variable here. And there's a stable increasing positive trend, which increased relative to the baseline. And as opposed to the last graph, this one's a little bit tricky because you can see the plus sign and the negative sign are reversed here. So again, another reminder to kind of think about what the outcome variable is. So the high numbers in this case represent a worse outcome. So during the baseline phase, the client's problem exhibited a stable, increasing negative trend that would have continued without the intervention. And to make matters worse, the intervention implemented was associated with both negative discontinuity and stable, increasing negative patterns in client problem relative to the baseline. So as a result, the client experienced even further deterioration. Again, so as a clinician, this would be like a strong warning sign that you needed to try something new. All right, so another kind of tricky one here, but you can see the client problem exhibited a stable decreasing negative trend during both the baseline and intervention phase. So likewise, again, the baseline would have been expected to continue without an intervention. However, associated with the intervention phase, there's a positive discontinuity, so a temporarily increase here relative to the baseline, but it's also kind of ambiguous whether or not the intervention was associated with improvement or potentially no real change. Because at the end of the baseline and back to the end of the intervention, they would have kind of ended up in the same place altogether. It's a good idea to consult with your client to figure out what they might make of this pattern or what they think this might mean. So here we have an example where the client experienced no change. The client's problem exhibited a stable, decreasing negative trend in the baseline period that continued on into the intervention period. So in this case, the intervention was implemented and not associated with any effect, positive or negative, and no real change on the client's problem. So now that we've wrapped all these up, you can see that all these examples have clear straight line data, but in the real world, that's probably not going to happen. You're going to have a little bit messier data than the ones that you've seen for these examples. So just to kind of summarize this discussion on visual analysis of SSD, visual analysis is a tentative approach and useful for making quick approximate judgments. However, when the data is relate to important content, such as whether or not to terminate, or when there's a doubt about the clarity of the intervention or data, non-visual and statistical methods should also be employed to analyze the data. So that way we can see if there's a statistically significant change and the effect size of that change and whether or not it's strong enough to really show us anything additional about the strength of our intervention. So a lot of people say that they don't really like statistics, but for this course, Measures of Central Tendency, I'm hoping that you all have some experience of what mean and median is. So mean, again, is the average of a sum of numbers, where the median is the middle number. So if there's an outlier, a median is probably going to be more accurate measurement of what the central tendency is. So median is a value above and below which 50% of data scores fall. So if we took all the data and measured them from lowest to highest, median would be right in the middle, versus mean is the sum and average of all those measures, all those individual data points. So upon visual inspection of this data, the directionality of the data is somewhat unclear. There's a somewhat stable increasing overall trend. So we technically could calculate the mean of this series of data and superimpose a mean line, and it would look like this. But this probably doesn't represent the data all too well, because then you kind of lose that trend line. That's a positive increasing trend here. So another thing that we do within single system design, if we do see a trend like this, is superimpose a acceleration line. So the acceleration line gives kind of like a moving average of the data points and helps us to kind of determine where the trend might be going based on the average of the data points and whether there appears to be an increasing or decreasing trend. So just a point of caution here is you can see that there's quite a few data points here. There's approximately 14 in this data set. But if you only have a few data points, they can be really susceptible to outliers. So with your own data, just be careful to keep that in mind if you don't have too much to work with. So if we were compared to that previous graph to this one, we don't really see any kind of trends here. This is an example of cigarettes smoked per day, and there's a lot of fluctuation of up and down. So here, there's some kind of outlying data. There's certainly some high points and low points, but there's no significant outliers. So I would say in this particular case, it's good to use the mean, I would say. So the mean being 6.3 for this baseline data here. And I think that characterizes the data pretty well. Versus if we were to look at another student's project, versus if we were to look at this data, there's this similar data for the first 12 days, but on day 18 we can see this really big outlier where there's 25 cigarettes smoked, just chain smoking like crazy that day, and that's going to pull up the average for the rest of the data points. So in this example, it's probably better to use the median, which is going to be a better descriptor of the data that's in this data set. So the median here is 6.0, which is similar to the previous graph. You can see it's almost a little bit lower, which is also, I guess there's some pros and cons of that, but as opposed to the mean being pulled up by that one outlier. 6.0 median is a little bit more representative of what's really going on here. So just for a point of illustration, if we took that day 18 and instead of having it 25, we flipped it to 10, the median wouldn't be affected. So you can see that the median is a little bit more robust than the mean is to outliers. So that's why we would use the median as opposed to the mean in an example like this. So some other measures of central tendency or measures of variation is the range, the trim range, or the interquartile range, and standard deviation. I'm hoping that you're already pretty familiar with range and interquartile range, and you're probably more comfortable with standard deviation than you think you are. So a real quick, easy example here of range. The difference between the lowest number and the high number here, we've got a range of 0 to 5. So simply the range is 5, right? The difference between the lowest and the highest number, you could say there's a range of 0 to 5 here. So when you're reporting on central tendency, it's important to say both what the average is and what the range is. So there's a difference between having an average here, which would look like it would be 11 divided by 5, which is just over 2 with a range of 5. That's different than having, if we flipped out the other values of 1, 2, and 3 with 5s and we had 4 5s, then your average would be a little bit closer to 5, but your range would still be the same. It would still be 0 to 5. So when reporting on mean, it's also important to report on range. And also it gives richer detail on your data. So here's a case example where a client's receiving palliative care and tracking the number of daily crying spells. So you could see that the baseline mean is 2 and the intervention mean is 2 as well. So you might think that there's really no change here. However, if we looked at the range, we could see that there was a baseline range of 5 versus an intervention range of 2. So even though the average number of crying spells is the same, there's some mood stability going on here, because some days during the baseline she would go days in a row with no crying spells, and then some days just be completely despondent, versus during an intervention phase it's a lot more predictable and there's some mood stabilization going on here. So similarly to mean and median, if we do see an outlier, like in this data set there's 13, which is a significant outlier here, then we would use the interquartile range. So a computer can find this for you. Otherwise, there's ways that you can do it by yourself, by hand. But either way, it's important to know conceptually that it's the middle 50% of observations and getting rid of the top 25% and the lowest 25%. So with the data set that I just showed you, number of crying spells, you can see that here's the middle 50%, which is the interquartile range, which is 1 to 5, and pretty much unaffected by that one day where there was 13. And gives you a little bit more accurate idea of what the data or trends in the data actually show us. So just to kind of wrap up, if there's no clear increasing or decreasing trend, then we can use mean and range. Or if there is no trend and outliers, then you would use median and interquartile range. So that's why it's important to do a visual analysis of your data before you determine how you're going to write it up. So if there are trends, then it doesn't really make sense to talk about central tendency. Versus if there's really no trends and variation in the data, then we would be a little bit more comfortable using measures of central tendency and variation.